Morning everyone, it's time to talk about springs in a short video. Here on the screen I have two gears that I placed on the screen. The first gear is on a shaft and the second gear was simply placed on its shaft. I've set the first gear to have a motor, and if we tell it to go, the top gear also runs. The reason for this is that it is assumed that there's a grub screw on these collars and that it's tight. But this isn't always what you want, of course, so for every object there is a checkbox called lock to shaft. If I uncheck that on the motorized gear, you can see that it no longer drives the upper gear and the shaft itself is stationary. If I turn on the shaft lock on that one, we reset that grub screw and away we go. Now, there's a second option here in that you can add springs to objects. So let's take a look at this second gear. When we lock it to the shaft, a second selection shows up called shaft spring. It gives us the option of putting a spring on that shaft. If I check it, I'm given four options. Let's ignore grounded for a moment and look at the next three options. First, we have damping. Damping is how fast a moving spring will slow down, how much energy is lost on each cycle of the spring. We're going to set it to 0 for a second. Frequency is a zeta function for springs. It sets the stiffness of a spring by virtue of the frequency expected from a spring. Now, the faster a spring toggles back and forth, the stiffer that spring is. So we can slide that up as a measure of strength of spring. And then we have an equilibrium angle, which is the natural angle of that spring, the 0 point. And at the moment, you can see there's an arrow on the screen pointing at 0 degrees. And this sets the angular setting for that spring, because you may want that springy thing to take off the second you hit simulate rather than have to be torqued by something before it shows its springiness. So if I, for example, set this equilibrium angle down from the 0 angle and tell the system to go, you can see that although the second gear is locked by grub screw to its shaft, it's on a spring and it sprung to its original point before the shaft could begin to move it. So in other words, it now has a spring attached between the gear and the shaft, and as the shaft turns, it's winding up the spring. So if this gear was driving something, it would hold for a moment while pressure builds up from the spring before it begins to drive its neighbor. You can think of that as sort of a spring-based soft start, or use it in many other ways. There's a secondary option, however, to this, and that's to select grounded. If I select grounded on the spring is no longer really connected to that shaft. It's now connected to a spring which is connected to the world or to your static frame, whatever frame you're going to build to hold your device. And that means that if I tell it to go, you can see that the spring rotates to its equilibrium point and no longer follows the shaft. It is sprung only to that point on the system. Now, you'll notice it sprung to the point and it stopped, even though I have no damping. One of the reasons for that, if we go to expert, we can see that there's an angular damping on any object that can be set. And I'm going to turn that angular damping down to 0 and see if that makes a difference. Now you can see this spring simply toggles back and forth and never seems to stop. This is the definition of a harmonic oscillator, a spring with no damping. So it will continue to go back and forth. It may slowly lose energy and eventually stop, but this is the type of spring you would use inside a clock escapement or a chrono escapement to keep the main spring going back and forth. Now, normally it would damp a little bit on a true spring, so your escapement would be adding energy to the spin one direction or the other to keep this harmonic oscillator going. However, by correct setup of mass and so on, you can simply have that oscillator run pretty much forever within ticker. Let's stop that. Let's turn off this motor because we're no longer using it and hit simulate again. Oh, sorry, I must have missed turning off the motor. I did. Make sure you check these check marks carefully when you go to change something. Sometimes you miss the checkbox. All right, so here we can see, even with no motor running, it makes no difference. As long as this object is on a spring and that spring is grounded, the shaft will have no effect on the object and it'll simply operate as a harmonic oscillator. Now, if we set some damping onto this particular guy's spring, let's pull that up a little bit. We can see that the gear comes to a rest much quicker. And if you have a higher damping, you can stop it almost immediately. This is the rotational spring within ticker, and you can use them on pretty much any object and on any shaft. Whenever you check lock to shaft to tighten the grub screw, you'll be presented with the option of a spring. So that's pretty much all there is to be said about springs at the moment. You can use them in several ways. Something could hit an arm, which is loaded with a spring, and that would, of course, bounce it off, and so on and so forth. But I thought I should show you the settings for a spring and how to deal with them. Other than equilibrium angle, damping, and frequency, there's really nothing more to worry about with the springs. Have a good day.